Thank you for joining us today. I'm John Westgate, and I run the business development group at TVU. I am joined by media technology strategist John Solomon, and from InSync, James Shepard, the chief technology officer, and product manager Steve Cole. Today, we're going to get an introduction from John to TVU MediaMesh, which is a cloud-first modular infrastructure for live media that couples asynchronous microservices with a remote shared memory fabric, providing the flexibility and performance needed to easily build end-to-end live video workflows at any scale within one seamless global platform. And then we are going to get an overview of InSync FrameFormer and how the integration with TVU MediaMesh provides seamless routing of content between any location and destination, how premium motion compensated frame rate conversion for live events preserves image integrity, even in fast motion content, and how with an efficient cloud and hybrid deployment, you get flexible pay-as-you-use access. I saw one hand raised. We will take questions at the end, so please put them into the Q&A tab at the bottom, and we will answer as many of the questions as we can. If we can't get to everybody's question in the time allotted, we have your email address associated with the question, so the appropriate person from InSync or TVU will follow up. To reiterate at a high level, TVU MediaMesh is a next generation dynamic container-based platform purpose-built to handle the rapidly evolving demands of the modern media industry. Based on over 10 years of cloud-first SaaS service innovation, it delivers low latency, high reliability, and seamless access to media globally. Very important part. It was initially introduced at IBC 2025 with about 12 partners. We've doubled that to over 25. And MediaMesh enables them, partners such as InSync, EVS, Grass Valley, and VizRT to rapidly build, easily deploy, and easily operate advanced media workflows at global scale. We'll ask John to talk a little bit more in detail about MediaMesh.
All right, thank you, John. Welcome everybody to today's webinar. I'm going to give you a brief understanding of what MediaMesh is, explanation of it, so that we can help you understand why and how InSync is integrated with us. So what a lot of people know and understand is that the cloud is really powerful for elastic live media production. It has the flexibility to run what you want, when you want, where you want, and only pay for what you use. It has the scalability to greatly expand ingest distribution or processing needs based on the event you're doing. So if you're doing a small event, you use only a little bit, and if you're using a big event, you use a lot. But you don't need to build to do a big event. It allows you to go to time to market faster, so you can test and iterate new ideas and new solutions. And the industry has gone from somewhat 6-month releases, typically around the trade show times, to monthly or even faster releases. So that's feature releases, bug fixes, new functionality. Of course, there's potential cost savings when you go to elastic production, and there's definitely some carbon dioxide reduction, which is it's just still a thing that many customers are looking for. So with that, we've built the MediaMesh platform, and as John said, we have 2 decades of 2 decades of technology behind this. Of course, we have 20 years of our TVU pack uh, aggregated link production with our connectivity products. And then we have 10 years of our SaaS products, which use versions of that link connectivity. And so MediaMesh is the underlying applications, the underlying containers that power applications. So if you think of, if you're familiar with some of our products like Media Hub or Channel or Producer, those all use containerized services underneath. So those are many microservices that are running to handle ingest, demux, decode, transform, remix, and so on. Those run within our platform on what we call MediaMesh, and the applications run on top of it. And as part of that, we have partner applications that can run within MediaMesh as well. So what we're going to hear about from InSync today is their application actually running in a container in our environment. So in the middle here, you see that we've got these green and purple container boxes. And so some of those, the green ones represent TVU native services, and the purple ones represent partner services. So this could be frame rate conversion, it could be watermarking, it could be audio mixing. There's lots of different services that happen, and to be very transparent, many of the services are competitive with our own services, which is fine because we've built our services purpose built for our customers at the time. And we know there are many, many other customers out there that have other functionality they need that we might not support, and we embrace our partners to come in and do that. So again, in the middle, we've got these microservices that run. These are all driven by APIs, which the applications control to make the UIs work and to make the functionality happen. And it's all underlined by the global media mesh, which is a global shared memory allowing applications to read media as if they were local. And it expands beyond the boundaries of any facility or LAN or VPC. And so that's a really important part, is it's connecting those bespoke systems. The other important part is the ability to turn up any of these services you need when you need them. So if you need frame rate conversion today, you turn it on. And if you're done using it, you turn it off. If you need it for 24/7 for perhaps our TVU channel and you're doing international distribution, turn it on and run it. And it's all managed services under the hood. The last thing I'll say regarding this slide is, while this is all showing our containers and services running within our platform, we fully support running them in your own platform, whether that's on your own cloud, in your own environment, or even a hybrid model. And so that really allows connections between bespoke systems that may or may not have been able to connect before with other systems. So you can run a system on premises and a system in our environment, or a system in your own environment in the cloud, and they all can connect. So how does the technology work? The core underlying technology is our timing. So our origin timestamps are maintained through the entire process. And what's an origin timestamp? As soon as a TVU service gets media, it timestamps it. Now I'm specifically saying media because it could be audio, video, metadata, metadata, any sort of signal that comes in, media that comes in, it's timestamped when we receive it, and that timestamp is maintained through the entire process. So you have two video channels here, or multiple video channels and multiple audio channels coming in. Those are stamped if they're using media mesh technology at the front end. At the point of acquisition, they're stamped there. We can realign them when they arrive because public internet, of course, does not maintain synchronicity across paths. So we can align that when they align. And then further, as this graphic is showing, vision mixing often takes more time than audio mixing. And so we can account for that. And when we remux the signals again, those and release them out of the environment or to another part of our environment as a mux, they are automatically aligned. And that is the really important part when you are doing this global shared memory, is you could have a audio, video, and metadata that is all coming on different networks or across multiple networks, and keeping them in sync and aligned, not just among themselves, but across multiple sources that are coming in from the same place, is really, really important. And then once they're in, doing a process in the cloud can be is asynchronous. So all of our processes, all of our containers are asynchronous, and they resync at the point where they need to have audio and video aligned. So I have one more slide on the bigger picture here. So this is a similar to the 2 slides ago. And here you see we have some key partners that are some early adopters, if you will, that are on this slide, especially InSync, running in our own environment. You have the API connectivity at the top, where EVS Cerebrum can control our APIs and handle functionality within MediaMesh. So whether that's routing or even switching, you could do that with EVS Cerebrum. And then we'll be talking about this more at NAB, although we did show a preview at IBC, our connectivity with Grass Valley and MXL. So the connectivity here, there's a really interesting model where you're at perhaps in an MXL facility and you need to do distribution outside of that with frame rate conversion. That's what this picture is showing you right here, is the ability to bring together the preferred or best of breed services you need to complete your most efficient video pipeline. And then, of course, at the bottom, this slide shows that we can host it anywhere. It could be on our platform. It could run in your data center network, your cloud service. All of these are fully supported. Of course, the orchestration maintains in our environment. And then finally, the simplicity. So FRC, frame rate conversion with just a click. This is a screenshot of our destination builder for MediaHub. And so within MediaHub, there is within all of our services, the video source has a header that tells you what type of media is. Is it 1080? Is it 720? Is it 4K? What is the frame rate? And for destinations, we have what's called an encoding profile, which is what is the output going to be? And so there's 2 ways you can do frame rate conversion. You can do best effort using open source underlying tools, which for proxies may be just fine. But if you want to do a higher end encoding, then you would click, and John, if you can click this, there should be an animation. That's all it takes. InSync reads the header information to know how to set up when we instantiate InSync, we read the header information to tell it what the source is and provide the profile information to tell it what the output will be. And then it starts at ephemeral container and runs for the duration of the event and then terminates it. And so there's nothing you have to do. You simply tell what encoding profile you want to go to this destination, and MediaMesh and InSync do the rest. And so with that, I'll turn it over to our next part of this.
So I'll stop sharing there and allow James to take over.
Okay, so I'm definitely going to be slide light. So can primarily communicate the ideas verbally, and a couple of slides just really nail the point home a bit later. Just in case anyone joining the webinar isn't familiar with or hasn't heard of InSync before, I was just going to give a very, very quick introduction to the company. So interestingly, listening to the TVU history, we're now 23 years in business and producing product. So originally we developed bespoke designs, and we also went to market through OEM channels. And in the early years of the company, our focus and the deployment of our technology was through hardware-based boxed product. So this is technology that's using FPGAs to achieve the processing. But we've been on the same exciting journey as the rest of the industry. And we've really thrived in the challenge of taking that intellectual property portfolio and making it available as virtualized and software-defined implementations. So what is our technology? So we are specialists in media processing. As has already been illustrated, media has a breadth to it. And of that media processing, in particular, we're well known for addressing the problem of standards conversion. Now, often when conversion's mentioned, in a lot of people's minds, that's linked with the word transcoding and the choice of protocol, codec, and container in order to share media content. InSync actually operates at the layer below transcoding. So rather than being concerned with storage and bandwidth and compression, we're really focused in on how we deal with, how we process, how we transform the underlying video image representation. So if we have any given particular video standard, there are many properties that make up its description, but the big three that I always touch to are its scan type. So is it an interlaced or a progressive representation? Its resolution, so simply how many lines, how many pixels. And then thirdly, its frame rate. So this is how many images are being captured per second in order to convey motion. And all three of them are really interesting problems as an engineer to tackle, because at the end of the day, none of those three aspects of media processing have a pre-described method by which they should be achieved. There is no thou shalt standard written that explains exactly what and how you should achieve those processes. And it's very human and subjective assessment as to how naturalistic the result of those media transforms is assessed. But it's also fair to say that of those three video properties and managing a change in them, that the third, the frame rate change, is by far and away the hardest of all those three problems. So there are many platforms that can address a scan type conversion or a resolution conversion. And the differentials between those solutions are likely to be more modest. But there's very few providers out there who have actually tackled the problem of frame rate change and achieving it at a high quality. So that's giving a transparent result that maintains all of the fidelity present in the original signal. So how is this relevant to MediaMesh and the workflows that people are deploying there? So that was a fantastic introduction we got there from John, and I think in there we got the word international, which is absolutely key. So if we are distributing, if we are sharing content between different countries, different territories, and different continents, sooner or later, we're going to hit the problem of mismatched frame rates. We might wonder why we've ended up with this annoying and difficult problem. So I could wave my hands and say historical reasons, and hopefully it makes logical sense if we actually recognize that in those early decades of television production, the engineers developing those systems, ultimately their hands were tied. They were in effect obligated to develop systems that were sympathetic with and compatible with their power grid frequencies, because those analog systems were simply susceptible to all forms of interference, that if they weren't matched, it would just impact unacceptably on the image reproduction. So we find ourselves in the modern world where different regions operate with different frequencies. And the archetypal examples are that in the US and Japan, we have a 60 hertz power grid and video frequency, whereas in Europe and China, for example, the systems operate at 50 hertz. And so when we're bridging those boundaries, this is a problem that we really are well advised to be aware of. And that's actually one of the reasons why the opportunity to speak on a webinar like this for us is great, because it's not necessarily obvious that you have a problem. If we go back a number of decades, with these more dedicated and bespoke systems, if you attempted to connect a signal with a representation in one frequency to another unit or system expecting a different frequency, invariably you would end up with nothing at all, or something that was obviously mangled and a source of concern and a problem that you should be worrying about. Since we've moved to a far more IP-centric domain and a software-based domain, it's definitely true to say that systems are very often more flexible. And in that, they will attempt to deliver something as successfully as they can. And again, in the introduction, we heard that great phrase, best effort. Lots of systems are capable of delivering their best effort. And occasionally, that's not a problem. But it's worthwhile being aware that it could be a problem. So you may silently be obtaining a best effort and actually degrading the perceived quality of your content when it reaches the end viewer far more than was necessarily obvious. So let's try and grapple and understand better what that deficit is, how it comes about, and what the impact is. Let's take, for example, we're moving from a 50 hertz to a 60 hertz domain. In that situation, we've actually got a deficit of frames. So the simple fix, the simple solution, is that we simply have to duplicate some frames to make up the deficit. And actually, if we duplicate or we copy and reproduce 1 in 5 frames, simplistically, we've solved the problem. Likewise, if we start in a 60 hertz domain and we're moving to a 50 hertz domain, there we have a surplus of frames. And in that case, we will be discarding 1 in 6 frames to effectively achieve the same thing. Now, if we were to capture that stream and frame step and pixel peep the result, we wouldn't necessarily have any idea that there was a problem because we've only copied video images or video frames or dropped them. But if we inspect any individual one of them, they look intact. They look as good as the source. It doesn't appear to be a problem. The problem is at the end of the day when we view that result live in real time. So what's the effect of this dropping or duplication? All image elements, all moving image elements that in the source have their original naturalistic movement, particularly if we're talking about any form of real world object, they have mass, they have inertia, they take time to accelerate, they take time to slow down. Invariably, they move slowly and smoothly to some greater or lesser extent. When we introduce dropping and duplication, every one of these moving elements suddenly undergoes a non-physical acceleration. Effectively, they kangaroo hop forward in time several times a second, or they stop dead in their tracks, again, several times a second. And this hopping backward and forward in time is clearly a very unnaturalistic movement for any visual field that we're looking at. And furthermore, that's a fundamental problem when we're viewing that content. When we want to view a moving object with clarity, subconsciously and effortlessly, we achieve that by eye tracking. We have the ability subconsciously to follow the region of interest with our eyes. What that actually does is it freezes the image of that object on our retina. Because it's then frozen, we can see all of the detail within that moving object, all of its textures, all that information that we're interested in understanding. When this object starts moving unnaturally forward and backward, our eye simply can't keep up with that. And what we end up with is multiple imaging. Now, there's various adjectives that are commonly used or have been used in the industry to describe the effect. So one of them is judder, another is blending or blurring. You may have even heard the term ghosting said. And when that blending occurs, again, from a technical standpoint, all the high frequencies that describe those textures and edges of the real world content get degraded, they get blurred, they get nulled out. And additionally, because the effect is unnatural, we lose the sense of immersion that we're seeking to achieve with so much of our content that we're sharing. That's probably the point at which words don't help anymore, and when a picture really just helps cement the idea. So I've just got a few examples here illustrating the difference in the perceived result to the end viewer between that simplistic or low quality conversion and a process which actually performs a more intelligent conversion. So you'll see on the two examples of this winter sports content on the left, you'll see the multiple imaging effect at work. And when the process is compensated for, then we end up with the same level of clarity that we had in the original content. So I have a second example. In this case, it is some football. And again, I definitely find most people don't argue with me when I say it's more naturalistic for players to have 2 arms rather than 4. So you'll see here, there's so much that we're interested in as viewers. We as content distributors know that there are concerns of our sponsors. But for the end viewer, they're interested in the expressions of the player. They want to see the gameplay. They want to know the movement of the ball or whatever other feature. As I say, sports is full of movement, and movement is what we're ensuring is dealt with clarity. And while you're looking at these still examples, I can tell you that, in fact, the perceived effect is even worse than this because it modulates over time. As the two frequencies interact with each other, the level of blending and blurring and judder changes rapidly several times a second. So, in fact, if we were to view this as live video, the effect would also pulsate or beat, to use another technical term. Now, unfortunately, Zoom isn't the best guaranteed conduit for showing high fidelity, high frame rate video. So that's why I've used these stills to illustrate points here. But ultimately, the potential benefit for a higher quality frame rate conversion is best established by taking a piece of content and actually just comparing the two results. So what is the fix? What do we do to solve this problem? So we've already had this term motion compensation introduced. Well, in order to compensate for motion, we actually have to measure that motion in the first place. And that's indeed exactly what we do. The challenge is to identify the motion of every moving element within the image and describe that with precision and accuracy. And once we've done that, we can compensate for the motion and synthesize the frames that would have been captured by the camera operating at the desired output frequency had it been there filming that scene. And if that sounds like a difficult thing to do, it is. And it's what's kept me fascinated and exercised as an engineer for a couple of decades now. So at this point, I've blasted you with quite a lot of technical terminology and science there. So I'd like to hand over to my colleague, Steve, who is going to take a slightly different perspective over what this technology can do for us.
Thanks, James. Yeah, I'd just like to touch on a few of the other advantages of the TVU integration, if I can. So as I think we've already mentioned, historically, motion compensated frame rate converters were big ticket kind of CapEx items and generally located in a central facility. Often there could be racks of bespoke, power-hungry servers, potentially dedicated just to this task alone. So technically, they need maintenance, expert operators, and could potentially be running 24/7 using a lot of power. Now, as James showed, some of the main benefits of motion compensated frame rate conversion can be seen in fast-moving sports, sports such as football, motor racing, athletics, tennis, those kind of things. All these events and matches occur over a relatively short timescale and have active and inactive seasons, meaning historically recovering the investment in these assets could take a long time. Now, as production workflows are evolving to become more distributed and software-based, it allows the frame rate conversion challenge to be solved in a much more efficient way without sacrificing that all-important quality at the destination. By providing a simple, overhead-free conversion option as part of MediaMesh, users can tap into FrameFormer technology without having to make big investments and route local sources to international destinations all at the correct frame rate. Now, because the technology is available as a service, it can also be used as and when required, and the capacity can be scaled to meet demands, which can vary enormously over timeframes, as I think Jonathan kind of showed earlier at the beginning. For example, the production of a football league may have a handful of midweek games to distribute, but be running 30 or more games on a Saturday, with possibly some cup matches thrown in as well. So having the flexibility to cover individual requirements rather than planning for the maximum can also be a huge cost benefit. Another benefit is that FrameFormer was originally developed as a cloud-based solution, which makes it an ideal integration with the MediaMesh architecture. When I say FrameFormer, I'm talking about the software product, not necessarily referring to the earlier FPGA designs that James mentioned earlier. So FrameFormer is also a proven technology, having been evaluated, approved, and used by some of the largest broadcasters, events like European Championships, major golf, tennis, and cycling events, and for exporting local premium leagues for global consumption. So one customer even ran a blind test of FrameFormer technology against a well-established competitor and asked their engineering team to decide which conversion they preferred. Well, the result, 40 out of 40 engineers chose FrameFormer. So we believe having FrameFormer integrated in MediaMesh creates a very powerful cloud-native solution for global live production. At that point, I think I'd like to hand back to John, if that's okay, for take questions. Shall we do that?
Yeah, let's move on to some questions. I think following up on what you were talking about there, the first question that we've got, and let me make sure that we've got the right slide up, Q&A, so no one thinks we're at a different spot. The first question that we've got is, when I've seen motion compensated conversion equipment in the past, it has been in very large, say 4U or 6U racks. Presumably the results from software are from a lower quality to that achieved by dedicated hardware. James or Steve?
Yeah, that's definitely one for me to pick up on. Now that makes a lot of sense. As Steve said, these were well understood historically to be major capex systems, so it wasn't a surprise that they did the size of a small fridge. And I think it is for that reason. It's sometimes hard to imagine that you could port this sort of dedicated system to a software-based definition and have the same quality. Certainly, one thing that we've had working in our favor is the fact that Moore's law has remained true for a very long time. And so the processing power of any processing platform has increased tremendously. So I'd just like to reassure everyone listening that not only have we matched the quality that could be achieved in the systems that people were familiar with in the past, we've absolutely exceeded it without a doubt. It's routinely possible for software to even outperform dedicated solutions. Certainly as developers, we can iterate that much more agile way as we're constantly learning, and we benefit from cooperative relationships with rights holders in order to ensure that our solution is bang up to date. Again, if I can't persuade you, the proof of the pudding is always in the eating, and we're always absolutely delighted for people to make their own assessment of how well the technology performs.
Thank you, James. Certainly a call for trying it is always the best. We've got a couple of questions for John Solomon that are related, so I'm going to ask them sort of back to back and let him have a stream of consciousness since they're related to time stamping. Wouldn't we need the timestamp at the point of origin to ensure different ingest signals are aligned by the time it gets to TVU in the cloud? And how are the sources time-stamped? Are they stamped by location of origin or globally? If globally, what's the time source?
All right, two very good questions. I'll answer the second one first. It's a little bit shorter and hopefully simpler to answer. Timestamps are based off of epoch. So typically an NTP-like source is what we derive our origin timestamp from, and that carries through. And so it sticks to each frame as it processes through the system. As far as timestamp at point of origin, when a TVU service or hardware is used at the point of origin, the TVU timestamp is maintained throughout the cycle. Of course, one of the advantages of MediaMesh is the ability to take any media format in and produce any media format out. So when other tools are used for ingest, for example, an off-the-shelf encoder, MediaMesh will use the available timestamp within the transport, such as PTS, to align sources. Regardless if there is a PTS or no timestamp at all, whenever the media enters MediaMesh, the timestamp is retained of that point of entry. And so there is, of course, functionality to manually skew early arrivers to align with associated signals. So there is some control over that. And look, we would be very happy if every signal in the world had an TVU origin timestamp. We have an SDK available for that, but we recognize that there are, just like there are different types of solutions for frame rate conversion or graphics or audio mixing. There are many, many, many solutions for ingesting media over IP or over SDI or some other protocol we have yet to discover. So, of course, we accept all of those when they come in, and we align them. We align them and allow you to realign them if needed.
Thank you, John. We've got a few more minutes here. So if you have any questions, please put them in the Q&A tab at the bottom. back to James. Does the InSync process need a complex setup or tuning adjustment for specific content?
Great question. So again, if anyone out there has had exposure to this technology, they'll already be aware that some solutions provide a multiplicity of controls and adjustments that can potentially impact the results obtained from this kind of complex frame rate conversion algorithm. And in fact, again, with that historical perspective, very often facilities would have their own expert assigned to manage one of these solutions. They would actually be responsible for configuring and keeping one of these units working. But that's quite a luxury. There's certainly only certain scales of enterprise and content values that can justify having an on-site expert to deal with just one aspect of the process. So at InSync, we've really taken the complete opposite approach. We want to make this as accessible and as simple and straightforward to use as possible. So we really see it as our job to ensure that we have a huge library of representative test content showing the entirety of the genres and image content that we're expecting to deal with. And we're going to do the legwork in ensuring that across the board we obtain the best result possible. And of course, if we've got a processing system, then it's crazy not to leverage it to do the work. So if we are making dynamic live assessments of motion, I'm sure it's a logical step to imagine that we can make live dynamic assessments of specific image properties and content types. And therefore, we can actually ensure that the process tunes itself without that operator intervention. So it's for that reason that very much the plan in making this technology available in MediaMesh that we can take advantage of the fact that it's simply set and forget. As we saw, we've effectively boiled this down to no longer needing that expertise. It's a one-click solution.
Fantastic. I think we've got time for one more question. And this would be for you again, James. How can I tell if motion compensation will benefit my content?
Absolutely. So first and foremost, we've hand on heart, we've made it very clear that the content this benefits is content that moves. Now, most video moves in to some greater or lesser degree, and the benefit is present at any range or scale of motion speed, but the impact will be greater if there are more elevated levels of motion. There's no two ways about it. Because these algorithms are complex and unique, they will have their own individual strengths and weaknesses with different content types. But ultimately, the proof of the pudding is in the eating. And so I'd absolutely recommend, if you have any thought that this process could actually benefit your content and its perceived value to your end users, particularly if you've made a big investment in acquiring with quality, having the right cameras, lenses, and lighting at acquisition, then if you're paying out on quality levels of bandwidth connectivity in production or distribution, then the last thing you want to do is let this one step in the processing chain take away that quality. So definitely, I recommend giving it a try.
All right. Thank you, James. And a natural conclusion then to our webinar today would be to say that you can see InSync and FrameFormer at NAB. They will be exhibiting in West Hall, stand 2215. And TVU is going to be also in West Hall, very close, 1717, and we will be demonstrating the as well the integration of FrameFormer and MediaMesh. So thank you everybody for your attendance today. We'll send the recording of this to you. Any further questions, let us know. But we look forward to seeing you. And thanks to James and Steve and John for their participation today. We appreciate it. Thank you very much.